no. How do you find the area of a circle?
Divide
12 times 11 and multiply it by pi. You're so close, Josh. I know that you're trying your best, and I do appreciate it. Area of a circle, we know this one. It's pi r squared. Now, the difference here is what we're going to talk about today is what's called a sector. A sector is a portion of a circle. So if you have a circle, what do you mean? Not, we might. It depends on how much of the circle you're looking at, and that you're kind of on the right idea here. Regular boring circle. A sector is a piece of it. A sector is a portion of the circle. Right? So it's going to be, it's defined, it still has the same radius as a circle, but the amount of the circle that it is defined by the angle. Just like we talked about yesterday, when you had that arc length was the portion of the circumference. So if you had the whole, remember the example we did yesterday where we said that we had a circumference of, what was it, 8 pi to go all the way around? And then we said if half of it was a semicircle, half of that was only 4 pi. Half of that was a quarter of it, it was 2 pi. And that was all dependent upon the angles. It's the same basic idea here. So if, let's say you have a circle that has a radius of 4. If you have a circle with a radius of 4, that means that the area of the circle would be 16 pi for the whole thing. You guys okay with that? Now, if you go back and start thinking about it, if I say that my radius is 4 and I wanted to know that, what's the area of that? It would be half of it. It's 8 pi. You okay with that? Because you're using half of the area. Well, that half of the circle is how many degrees? 180. If I did it again, if I wanted to figure out how much that much of it would have been, it would be 4 pi because it's a fourth of it. Okay? And that's where you were getting at it earlier. Same idea. How many degrees are in 90 degrees? Or how many degrees is a right angle? 90 degrees. 90 degrees is 1/4 of a circle. So the idea here for this thing called a sector, the area of a sector is going to be dependent upon that central angle again. It's going to be central angle over 360 times the area of a circle, pi r squared. Super easy to work with. Okay, it's very, very, very easy to work with. This, I don't think I'm going to go too crazy on this stuff today, or even into tomorrow. We'll take our little slow through it, which is fine. Okay. So again, what you're looking at here is circle. Bless you. I want to find the area of that sector. I have a central angle and a radius. That's all I need to know. And it's quite literally substitution like we did yesterday for a lot of these types of problems. Okay. So what do? Well, I don't know what it is off the top of my head, but sure. Yes, you're right, Josh. You're all right. All you're doing is just using the formula. Fill in the blanks, press some buttons. Okay. What's that? No homework yet. Okay. We'll have time today. Like I said, I'm not going to go. I don't think I'm going to go too. We'll probably do the. No, yesterday we did towards the end. We were solving like radius and stuff like that. We can do the same stuff with this. We might just wait to do that stuff tomorrow and get a little time in class. And something. Not exactly sure what. Throw things together. 120 over 360 times 6 squared times pi. Again, if you don't have the calculator, it works with the pi button. You put everything before pi in the calculator, hit enter, and then write your answer down with pi, and you'll be good. So this would be 36. So you get 12 pi something squared. This is an area, so we have to make sure we label it. Sufficient wait time, sufficient wait time.
They actually teach you that. They teach you
What, how to wait?
like they like say something, you teach them constantly have to wait for their feedback. They teach you
You know, it's one of those things that when you go through college and you take a lot of what are called your educational philosophy style classes, they give you so much information about different classroom techniques and classroom styles and management and all this. And they always talk about wait time. They talk about, you know, looking for certain scenarios and stuff like that. But over time, a lot of the stuff that you learn in school, which you guys probably have attested to as well, you don't use it. And it's the same with education. And I'm not going to lie. A lot of the stuff that I've learned and that I went through and take classes for was stuff that's like, it's really going to work for me. And that's okay. And that's fine. You get teachers that you learn what's, you know how to, you ever heard the term, you learn the feel of the room? You ever heard how people, they get a sense of the room? You get a sense of how people are responding to certain stuff. People that do like speakers and actors and things like that, they can sense what's going on, or they get the idea of it. That's kind of what I've developed. You kind of feel if everybody's looking at you like this and not saying something, that means they have no freaking clue what you're doing. But if people are kind of like, you kind of like, okay, this is the easiest stuff and for today, and so on. But yeah, you pay a lot of money for stuff you don't have. Yeah, college. All right, do this one.
Who wrote that down?
This one, they changed it. Why are circles so hot? It's supposed to be because they're. You're an idiot. Throw in the calculator, what'd you guys get? 45 pi? Sure. Centimeters squared. And there you go. Like I said, pretty quick. Now, there is a little weirdness that we'll do today. Not too crazy though. We're going to look at what's called the segment of a circle. Now, what happens here is that sometimes we're going to find what I will call, well, it's a badly drawn circle, but if you look at this, that would be a sector. You agree? Now, if I connect this, it becomes a triangle. Good. This then becomes the snow on top of a snow cone. You've never had a snow cone? What, you don't believe me? It's a rather large snow cone, yes. So what happens sometimes is that we're going to do these shaded region style problems. Again, it's not going to be terrible. It's pretty quick and painless. What I want you to think of is that the snow cone problem is basically, it's a sector, oops, it's a sector with the triangle cut out of it. Oops, that didn't work. Anyway, so it's a sector with the triangle cut out of it. So if I take this with it, I have to find the area of a sector and just subtract the triangle. Now I'm going to show you guys a really nice shortcut way of solving for area of a triangle today. Because if you look at it, what do you know about this triangle that's formed here? What do you know about those two sides? They're equal. They're always going to be this. I do that. They're always going to be equal because it's a circle. They're made up of radii. So you're always going to have an isosceles triangle here. Now, you're also going to have to know that angle in order to solve for the triangle. So what happens here is that there's a really nice shortcut way of solving for the area of a triangle given what I call a side angle side scenario. You guys okay if I call that a side angle side? So here's how you do this. When you have this area of a triangle, and this only works for side angle side, it's going to equal 1/2 side times side, move this down so I can have room, times the sine of the angle. Okay. What's that? It's a nice little shortcut way of finding areas of triangles if you have side angle side. Now, I could have shown you guys this stuff earlier with some of the problems that we have done, but a lot of times this scenario wouldn't have shown up. This scenario shows up pretty much exclusively inside of triangles, in circles, because you're going to have to know that central angle to be able to figure out the area of the sector. So we just reuse that central angle in order to figure out the area of the triangle. The sine of that angle. And we got a couple examples here, but we'll take care of it. It won't be so bad. Should write down that sine with the plug on your calculator. Trig function sine. Works that. Show what we got. Well, before we do that, let's do an example of that triangle real quick, so you guys get the idea of how that works. And we'll just say that these are 8s. Okay. How that works to find out that area. When you do that, you'll have a scenario where you have, we call that side angle side. Okay. And when you have your side angle side, this is more of an algebra 2 shortcut. It's just nice to show you guys it now because it's for music. Oh, where was it here? So what you wind up doing is this. Not using the triangle button to move stuff. Right, that helps. So you have 1/2 8 times 8 times the sine of 40. You're going to get a crummy number. A lot of times you get crummy numbers, or you'll get those roots depending upon what the degrees are, just like we've had in the past. We haven't done it in a while. Make sure your calculators are in that degree mode. Just make sure you don't get some crazy answer. Your screen should say DEG in the top right-hand corner. Just put it together. So if you do that, what you're doing in your calculator is this. And this wouldn't be a bad time to use 0.5 because it's quicker to type. Because you're going to get crummy numbers anyway. 0.5 times 8 times 8 times the sine of 40 and hit enter. There's the area of that triangle. It's a nice trick to have. Okay, it's a really, really, really nice trick to know. Okay. So let's see, 20. You okay with that? So then when we talk about finding the area of that snow, the snow on our snow cone, what we're going to do is we'll find the area of the sector and then just subtract the area of the triangle. So the area of the snow on the snow cone will equal the area of a sector subtract the area of a triangle. And by looking at that way, I think it's easier to say the snow of a snow cone than the area created by the segment in a triangle, a segment in the circle. So many words. Snow cone makes me think that it's warm out, not 12. Worst spring ever. Good luck with that.
Once it starts warming up,
So let's look at an example. We'll use this one. We'll find the area of the snow cone, which means we have to find the area of the sector, and then subtract the area of the triangle. When you get into these things, since there's going to be pies, there's going to be roots, there's going to be decimals, there's going to be all this stuff, it might not be a bad idea to find them one at a time and then use our answer button. Okay, here's what I mean. Find the area of the sector, subtract the area of the triangle. Formula for our sector again is what? Central angle over 360 times the area of the circle. So we have 60 over 360 times 18 squared times pi. And then the triangle, 1/2 18 times 18 times the sine of 60. So it looks like a big giant pain in the butt to do. It's super easy because all you're doing is pressing buttons. So if I do the first part, 60 over 360. Times 18 squared times pi. I get 54 pi. That's what my calculator says. You all right with that? If yours gives you the decimal, it's not a big deal. Or you just know that you want to write down 54 pi to start. And then go to the second part. The second part was 1/2 18 times 18 times the sine of 60. And I hit enter. I know that that answer I have to subtract from 54 pi. So remember how we've been using this answer button all the time? This is where it comes into play. I know that all I have to do is now is go back and write in 54 pi, because that's what I had originally, subtract my answer. And there's your snow on the snow. Using the calculator to your benefit is hugely important. It's a big skill to be able to pick up on. So this gives me 29.35.
Can't we just do 18 squared with side by side?
Yeah, you can do that. I didn't want to throw all of that together with the extra side square, because in the circles it will always be a side squared, because later on you can still use this same formula if it's side angle side no matter what. It doesn't mean if you know it's 3 17 degrees and a 12. That way you don't accidentally write 3 squared times the sine of 12. But yeah, in this case it's so what did I say, 29.35? Something squared. Not too crazy, is it?
No.
Whole extra formulas. You'll get all these formulas on your formula sheet, so you don't have to memorize it. Just how do you use them? We'll do one more. One more like that, and then I will do a combo area, not a combo area, but like a shaded region style that you'll have to figure out a couple of sectors. Not a big deal, you're just adding them together. So write it out loud. I mean, you know how to do it. You can't figure it out. So with any luck, the area of the sector, 90 over 360, 4 squared and a pi, subtract 1/2, 4 times 4 times the sine of 90. Let's see, so that's 1/4, is 4 pi here, I believe. Is that right? And then you had to subtract out, would it be 8? And that's whatever that decimal is, and you're done. What is it? Sure. And then this is meter squared. The reason why sine of 90 is 1, sine is what over what? You guys remember? I think it's SOHCAHTOA. Sine is what over what? Opposite over hypotenuse, right? So what's opposite the 90? And what's hypotenuse always divided by hypotenuse? It doesn't matter how long it, whatever it is, it's always going to equal 1. It's one of those weird ones. That's why we never worry about 90s and trig functions. Okay. Let me give you a handful of these. They're going to be out of the book today. The book actually has a good first set of problems, and we'll do a. It's okay, you'll be fine. All he does is. So let's do this. Let's try. I think it's on page 663. Was it 8 through 22, 23, 25. They're really quick. Okay. Tomorrow we'll get into more of the shaded region style problems and multiple sectors and things like that. Shouldn't be too crazy. Maybe pull up this problem. There's a text here. You don't have your book in front of you. I got a couple of them up here. You want to use your Chromebook. Go on, there's button around. You know. That's close enough. Here's a book then, you guys. Yep, yeah. Yeah, but yes. Remember, sometimes they'll give you diameters and not radius and things like that. You have to think your way through it from time to time because, why would math always be the same thing every single time? That would be too easy. Nobody wants that.